Hi everyone, we can start in a minute exactly at 6 p.m. so everyone else can come in. Awesome. Okay, so it's 6 p.m. So hi everyone. Welcome to our two-part webinar, which is entitled Test Automation, an Introduction to Robot Framework and Continuous Integration. So it will be today, May 20, and also tomorrow, May 21 at the same time. So get settled and prepare for an hour of learning with our automation experts. So to introduce our speakers, first up in our lineup, we have Jason Almonte, an ICTQB certified tester, advanced level test analyst with over 10 years experience in software test architecture, development, and automation. Jason is currently the test automation lead at Fontaine Group Manila branch. Say hi, Jason, before we move on to the next speaker.
Hi, everyone. Hello.
Hi, thanks, Jason. So next up on our lineup is Noel Sinshoko. He is an electronics engineer with specialization in industrial automation with over 9 years experience in the IT industry. He currently works as a test automation engineer at Fontaine Group Manila branch as well. So say hi, Noel.
Hello, good day, guys.
Thanks, Noel. And our last speaker is Carlo Valencia, who is an electronics engineer, Scrum Master, and software engineer with over 9 years of expertise in software development and testing. He is currently one of the test automation engineers at Fontaine Group Manila branch as well. So say hi, Carlo.
Hi everyone. Thanks for coming.
All right. So with that introduction, I leave it to the speakers to take the floor. So off to you, Jason.
All right. Thank you very much, Abby. So good afternoon and good evening, everyone. On behalf of the entire team, I'd like to thank everyone again for joining our webinar today. So my name is Jason again, and I'll be one of the speakers in this two-part webinar on test automation, specifically using robot framework. And here we'll be talking about the importance of test automation in today's growing demand for software applications, the things to consider when choosing the right test automation strategy. Then we'll be deep diving on robot framework, what it is, what makes it so powerful, and how we could help out, or how it could help out in us, to us meet how basically robot framework will be able to help us meet the demand for automating our tests on different levels across different applications. And tomorrow, we're going to talk about continuous integration and the need for deployment gates in software development with focus on TeamCity, one of the more powerful CI/CD tool. And finally, to wrap it all up, we'll also be talking about how anyone can get started with automating their solutions using robot framework. So for example, their environment setup, basic test automation, architecture, and useful libraries to kickstart your automation journey. All right, so allow me again to formally, reintroduce myself. So once again, my name is Jason Almonte. As Abby has already mentioned, I am a certified ISTQB Foundation level and advanced level test analyst with over 10 years experience in basically test development, automation, and CI. And during the past few years, I've had experience with working in different industries such as telecommunications and trade facilitation. And throughout those years, aside from being involved with all aspects of testing, from planning, development, automation, CI, and even customer deployment support, I've also been into many different roles such as test engineer, lead architect manager, and decided right now to focus myself with test automation. Now again, together with me are two of the best engineers I've had the opportunity to work with. So firstly is Noel, a fellow test automation engineer as well. So Noel, here to say a few words.
Hi, everyone. So I'm Noel Sinchoko, test automation engineer here at Webb Fontaine Group, Manila branch. So I've been in test automation since I'm in college, taking up the electronics engineering and specializing in industrial automation. So with over 9 years of experience in test development and automation, I work on different test automation projects and done a variety of test verification activities such as a regression test, performance, load, upgrade, and security testing, to name a few. So currently, I've been supporting the test automation and its continuous integration activities here at WebFontaine. So that's all about me for now. Thanks a lot.
Thank you, Noel. And last but not the least, of course, we have in the call Carlo Valencia as well, who is also working as a test automation engineer for the team together with us. Carlo?
Hi everyone. So I'm Carlo, one of the test automation engineers here in Fontaine, Manila branch, and I've been doing software development and testing for more than 9 years now. So hopefully everyone will enjoy this webinar today and tomorrow. Thank you.
Yes,
Thanks,
thank you
Jason.
very much, Carlo. And thank you once again to everyone that has joined this call. So again, for today, I'll be the one discussing more about robot framework. And of course, we're also going to catch Noel and Carlo for tomorrow's session. They're going to be discussing more on CI/CD as well as how we would be able to get started with automating your test cases. All right, so just quick, background. So we are all currently working with WebFontaine, a leading provider of solutions for trade facilitation powered by world-class technology, including artificial intelligence. The company develops new generation IT systems that take trade and custom processes to the next level for the benefit of the global trading community. It's currently deployed in several countries worldwide, and our solutions include single window platform for trade, paperless custom systems, cargo tracking systems, including regional interconnection of custom systems, and finally, collaborative valuation and classification programs. Okay, here's a quick fact. Software industry in general is one of the biggest industries around the world, with millions of software applications being developed and used globally. And with more and more systems undergoing digital transformation, it is expected to exponentially increase over the years. With that, web-based applications are among the largest, with over 1,197,982,359 websites across the globe as of January 2021. And that was, 4 months ago, 5 months ago. So imagine how much larger it's going to grow throughout the months, throughout the years. So in the company alone, in WebFontaine, we have over 40 different software applications covering many aspects of the trade industry. And most of them are web-based applications, with the rest being mobile-based applications, back-end servers applications, and desktop-based applications. So with that, as with all other software applications, the million-dollar question is, of course, how can we ensure the highest possible quality of our solutions and be able to release it at the shortest possible time to still gain, of course, the competitive advantage and keep up with the market's increasing demand? And the solution, of course, what we have right now, continuous integration through test automation. Now, let's take a step back first. What is test automation and why is it so important in software testing? Ask anyone and you'll probably have a variety of different answers. If you Google in the definition of test automation, the first thing that you'd probably get is that test automation is a testing technique that uses separate software from the system under test to control the execution of test steps as well as the comparison of actual outcomes with predicted outcomes. I know because I just Googled it earlier this morning, but in its basic essence, test automation is a technique which enables a system to execute and verify test cases for us. All right, so that's cool, but why do test automation in the first place? So first is for productivity. Bear with me. Imagine first having over 1,000 test cases in your smoke or regression suite, or basically just your product that you're testing, all requiring execution as several software features and changes gets committed to the repository daily. Even with an army of QA engineers, for example, or basically just engineers, it would be an almost impossible and not to mention cruel task to execute all of them manually, only to be executed again and again and again as software features are lined up for testing prior to the release. With automation, it's executed, or basically the test cases are executed for us, enabling us to focus on the things that truly require our attention, such as, for example, of course, designing new test plans to cover new functionality or features, optimizing the test suite, and doing process improvement initiatives, to name a few. With that in mind, actually, speed is something that goes hand in hand with it. As us, of course, as humans, we have certain limitations in terms of, for example, clicking and typing and doing all of these user actions. So we can only, do so much and do it, as quickly as we can. But with software doing it, execution and validation is no more than just a walk in the park for its speed and accuracy. Now, with productivity and speed comes a fast turnaround time for potential defects to be discovered, analyzed, and fixed as we grow in terms of the frequency of tests that could be done given a period of time. Now, again, going back, I'd imagine that depending on the complexity of the tests, perhaps an average person can execute all of the 1,000 test cases in 3 to 5 days, only to discover a critical block or defect at the end of the test execution phase. At the last day, on the fifth day, now, with test automation, especially continuous integration, tests could be executed on a daily basis during the night, even such that when the test engineer, for example, report to the office the following day, test results and system logs are already there for analyzing. I've even had the opportunity before to work with some projects that actually, automatically analyzes the logs for us and have already had some, proof of concept initiatives on basic troubleshooting recommendation system paired up with what the user could actually take to fix the issue itself, especially if it's an environment related one. So with that one, it's like a fully automated, troubleshoot, not only testing, but troubleshooting system as a whole. Now, in coverage, admittedly, again, as humans, we have certain limitations, not only on how much we can test, but also what we can test. So for example, test automation does not only cover use cases executed by an actual end user, but also execute and or simulate performance and security tests to our system. Again, for those who have already, have background with performance testing, for example, imagine wanting to simulate hundreds or even thousands of users concurrently using your web-based application all at the same time to check for any performance issue with the system. Now, this is something that's likely to happen in real life, especially, of course, that in terms of web-based application, the entire world could basically be using your application all at the same time. Okay, fifth is insight. So again, test automation is a vast and continuously expanding field. Apart from functional front-end testing, it can also execute otherwise more complex and tedious back-end testing, such as API and database testing, to name a few. Accuracy, again, as humans, we have certain limitations as test execution, with accuracy being one of them. There is a saying that we are only humans, and of course, as humans, we can and have a tendency to commit mistakes. Imagine an extended night shift just to fix or finish the 1,000 test case regression suite that you have. It's already past midnight, and then your eyes are already wandering in a faraway place. You want to go home, or you want to, already finish your work there. And it's really easy to make mistakes given that scenario. But with the system to execute those tests for you, you can be assured that that test execution is pinpoint accurate, so long as we design our testing scripts in a more robust manner. Seventh is stability. So something that we are going to discuss more in detail later, but basically, as one of the goals in testing, we want to catch as many defects as possible to keep them far away from the customers. I mean, of course, we would want to use a bug-infested system, right? So most especially for highly critical applications such as in the medical industry, travel, finance, and of course, especially trade as well. So with that in mind, we want the highest possible stability we can offer to them to have a seamless experience during software upgrades. So this is where deployment gates or checkpoints come in, and they are all made possible through test automation. And finally, with that said, automation, especially when used as a deployment gate, enables end users to have what we call as a continuous delivery and deployment, that when we ship out our products and product upgrades continuously, seamlessly with high levels of quality. And of course, at a rapid pace enough to meet the higher and higher demands of the ever-evolving market. So this is like the nirvana of the software development. And of course, as end users, this is something that we also want, that our system or application are continuously upgrading itself without us even knowing it. So that's actually already happening right now. And that's, of course, enabled as well through test automation, through continuous integration, deployment, and delivery. Right. Okay, so now that we have established the need for test automation, the next step is really on picking the best test automation strategy for us. This comes in many forms, with the test automation approach as one of them. And in terms of tools, generally, at least on how we started test automation efforts in our current project, as well as in our past project, we had to choose between the following major, you could say, categories or types. So firstly is the record and playback. Next is the keyword-driven approach. And finally is the script-based approach, of course. Okay, for the record and playback, it's basically a codeless automation that records user actions first manually done by the test engineers. It is then, or basically it then saves these recordings and enables users to play them again if ever they need to execute the test scenario. So this is basically, us, for example, teaching the system how to test an application first by first, of course, showing it to them. This is very much useful for simpler systems that requires us to quickly ramp up on test automation. And some examples of this are, as you can see here, RunnerX, Test Project, Selenium also has a record and playback. So these are some of the more common, more popular testing tools under record and playback. Another is to use what we like to call as the keyword-driven approach, which basically uses abstracted third-party libraries that test engineers can readily use to automate their test cases. Apart from them being ready to use or ready to use, they are also designed to be user-friendly with implementation in a keyword-driven or basically keyword-based approach, often BDD style or behavior-driven style, reflecting the actual actions that the end users can do to the application, such as clicking button, input text, element should contain text, etc., etc. So some examples of this are, of course, Robot Framework. We also have here Catalan Studio, and finally, Cucumber. All right. Last but not the least is we also have the script-based approach, wherein user actions and verifications are defined using locally developed functions, oftentimes extending core libraries, for example, Selenium WebDriver, and implementing on top of them to basically suit the needs of the application or project. So examples of this are the use of, again, Selenium WebDriver run on top of Python or Java programming language. Okay, now that we have, or now basically there are many things, by the way, to consider when choosing among these three, all depending on the solution and consequently test automation requirements. So in our case, we decided to compare them according to flexibility, maintainability, third-party support, complexity, robustness, user-friendliness, and of course, finally, popularity. Okay, now in terms of flexibility first, since keyword-driven approach and script-based approach uses code-level language, it's very easy to implement handlers to handle possible scenarios during runtime, such as, for example, slowness of the environment and or additional scenarios wherein we need to perform more complex operations to the UI as an end user. So with this one, it's very much, we could basically customize the test automation framework depending on our need. Now, in terms of maintainability, since record and playback as well as keyword-driven approach are all developed and maintained externally by third-party developers, it alleviates and takes off the stress of creating our own custom keywords just to, for example, open a browser or clicking, for example, an element. With ready-made keywords that are very straightforward, we are easily able to use them as basically as is and not anymore bother with creating, for example, in Selenium with WebDriver, we need first to create WebDrivers itself and then possibly use action chains, etc., etc. As compared with using script-based approach, for example, using Selenium WebDriver core. Now, furthermore, for any changes such as keywords, or basically such keywords are already creating or updating or maintaining, or basically these keywords are being updated by third-party developers already. So we don't need to anymore bother ourselves with constantly maintaining all of this. And we could basically already focus all our efforts on creating the test cases themselves and of course automating them. All right, third-party support. So in terms of third-party support, this is pretty much given that script-based approach being developed as a proprietary homegrown solution is not covered with any third-party support. So we have here as a winner, of course, the record and playback and the keyword-driven approach. Okay, now in terms of code complexity, and by that, how simple it is to understand and implement, again, record and playback as well as keyword-driven approach takes the ball as they are specifically designed to abstract the complexities of creating WebDriver, action chains, etc. And all the user needs to do is to either record user actions and or get the element locators themselves and call upon these ready-made keywords such as open browser or click element or input text or even wait until keyword succeeds for doing user actions and handle it properly. So later on, we're gonna show basically what those things are using robot framework. Okay, third to the last is this robustness. So in terms of robustness, keyword-driven and script-based takes this one again, since both are highly customizable and can easily implement robustness measures such as handling web element exceptions, stale elements, unclickable elements, slowness of the environment, to name a few. However, keyword-driven approach takes more advantage of this, as since keywords are already predefined externally by third-party developers. So it's just a matter of calling them, like for example in robot framework, we have here wait until keyword succeeds instead of defining a whole lot of try catch statements, for example, in code, unless of course absolutely necessary. Okay, next in terms of user friendliness, this goes hand in hand with complexity that again users are abstracted with heavy implementation, especially for these two. Basically, users don't anymore need to learn deep level coding, as the users just need to record user actions or call upon specific third-party keywords developed by externally, of course, to execute your user actions. And last but not the least, we have this in terms of popularity. So in terms of popularity, keyword-driven and script-based approach takes this because of the flexibility and robustness advantage it has over record and playback tools. And given the complexity of many projects and solutions nowadays, this is a generally basic requirement. And of course, solutions and applications generally, are expected to grow over time because of course of the increasing demand of the end users. Now, finally, given all of this, again, each approach have their own pros and cons, and it all boils down to what we really need and what our solution requires. So in our case, for example, a keyword-driven approach is the best option for us so that we have a flexible, easily maintainable, simple, robust, and user-friendly test automation framework in line with our future goals of having this rolled out to other stakeholders as well. All right, now in terms of picking the actual tool or framework we will be using for test automation, there is really an overwhelming amount of options to choose from. However, we decided to select from the following more popular ones, giving the highest value to us in alignment with our long-term objective of having a single unified test automation solution that could easily be integrated and used by anyone across the entire project. So may it be developers, test engineers, technical leads, etc., etc. So we decided to focus on the following. So we have here Robot Framework, we have Catalan Studio, Spark Framework, and Cucumber. Now again, each have their own pros and cons, and depending on the application you're testing, one tool might be better off than the other. So for example, to start with, we have, of course, Robot Framework, which is a general purpose all-around test automation tool, having a rich ecosystem able to support web, mobile, API, remote, database, and desktop-based applications, to name a few. It also allows BDD style testing and is keyword-driven framework which uses human-readable syntax that even non-developers, for example, can easily understand and even create their own automated tests from. It is also open source and easily extendable, as well as could be easily integrated to most CI/CD tools. And finally, of course, it also has intuitive reporting, albeit requires some scripting to meet more, demanding forms of reporting. The next one in our list is Catalan Studio, which includes a variety of functionalities revolving around web and mobile-based application testing. Similar to Robot Framework, it is also intuitive, keyword-driven, and easily integratable to most CI/CD tools. Some cons, though, however, for this one is that it lacks scripting language support apart from Groovy, as well as that is closely or basically closed source and have a relatively smaller community because of that. Third, we have here an equally, popular Spock framework, which is primarily a unit testing framework for Java and Groovy applications, but can be extended to support system and acceptance level testing. It also allows BDD style development with its built-in mocking library. And again, it could be easily integrated to most CI/CD tool. However, a possible downside of this is that for users, they need to learn Java and Groovy first to start automating test cases. Finally, there is Cucumber, which also supports BDD style development. And with that, it is also user-friendly, just like Robot Framework and with the rest of the frameworks and tools here. And also human-readable or has a human-readable syntax in the form of their keywords. The only downside of this is that It is mostly basically used in acceptance level testing with reportedly relatively slower execution time. And finally, it only supports web-based applications. So again, this all of this four testing tools, as well as the other testing tools that I've shown earlier, again have quite a lot of pros and also have a lot of cons. So again, depending on the application that you are testing, basically, and also your, of course, testability requirements, you might prefer one or the other in favor of the benefits it brings to you. In our case, we decided to go with Robot Framework as our framework of choice for the reason that, of course, as we wanted to have a unified testing framework across all different projects, regardless of its platform, of its architecture, you know, not just focusing on web-based application, but also being able to cater, of course, to like mobile-based applications, desktop applications, and all those things. With that, Robot Framework is the best fit for us as it supports all of these things. And for example, web, mobile, API, remote, database, desktop. And heck, as far as I know, it's even being used in robotic process automation. And at some point, I just learned that it's also being used in elevator systems. So that's how flexible Robot Framework is. And also secondly, we wanted to have a framework that is user-friendly and does not take too much time to learn, especially that we want quality. And by the extension of that, test execution and automation to be shared ownership and responsibility across all levels of development. And so having a keyword BDD style approach is the way to go. And finally, we also want a framework that is easily maintainable yet flexible enough to meet the ever-growing demands of the application, and with it being open sourced, third-party framework plus having a huge community supporting it, it wasn't really hard of a choice to make for us. Yeah, so which brings us to the question, what is Robot Framework and what is the fuss all about? Well, Robot Framework to start with, by definition, is a generic open source automation framework. And by automation, again, it really literally means automation in general, as it can be used to automate a huge array of applications and not just simple testing, but also process automation, robotic process, basically any kind of automation actually. Before I even worked with projects wherein we used Robot Framework to automate our day-to-day tasks, such as, for example, logging in test results to Jira management itself, KPI monitoring of certain servers, applications, email, software deployment, and of course, finally, testing. What it is that firstly, it is extensible, and by extensible, it can be easily integrated with virtually any tool to create powerful and flexible automation solutions for numerous different types of application. In a robot framework, as well as we'll see further, has a wide array of built-in third-party libraries that caters to every automation need. And if that's not yet sufficient, Robot Framework allows easy integration with any Python-based locally developed script as well. And actually, that's not only limited to Python. It can also execute, for example, or control basically remote applications and even run also Java-based scripts as well. Secondly, it is also open sourced, to which it's free and anyone can easily download it together with its libraries, modify and or extend it, use it directly to serve your basic needs. And as such, Robot Framework libraries, including the core framework itself, as a large community collaborating together to bring in new features to Robot Framework itself. So again, with this one in mind, since it's open source, it's free, it's basically, just out there for us to grab or to download, to use. Robot Framework and the libraries surrounding it is basically evolving and evolving together with the applications that are also using it as well. Third, Robot Framework can also be easily deployed towards most servers and test environments, as it is operating system and application independent. You can basically deploy a Robot Framework, of course, in a Windows machine or a Linux server. And also in my previous project, we have deployed basically Robot Framework as part of our what we like to call as a TaaS or a testing as a service solution, wherein Robot Framework was Dockerized and given to our internal and even customer user acceptance team to be used for their automated acceptance testing as well. Finally, is that it is user-friendly in a way that, again, being keyword-driven framework, functions defining our user actions are very much intuitive and human readable, as I'll be showing later. So it is literally like, reading the exact same test steps you would normally see in your test plan. So no fancy, naming conventions, special characters, underscores, camel cases, parentheses, and curly braces as you would normally see in your typical programming language. Just, plain human readable English as we'll be again seeing later on. But before that one, let's take a step back and know more about Robot Framework being very much flexible and extensible. It has an already wide array of standard libraries basically commonly used for test automation, as you could see here. So we have specific libraries for data handling, runtime getting of inputs, remote connectivity, operating system related functions, taking of screenshots. So we have the screenshot library for that one, and other useful functions such as the test event handlers like run on keyword or run keyword on failure, wait until keyword succeeds, run keyword if, etc., etc. However, what makes Robot Framework immensely powerful is that it has a wide array of external third-party libraries that could easily be integrated to it. So this is capability enables Robot Framework to do almost anything, and I do mean anything. So from automating web-based applications using the ever popular Selenium library, as well as the browser library here, to testing mobile-based applications using Appium library, to database testing using database library, to integration testing using HTTP request library for HTTP, and of course REST instance for testing REST or JSON APIs. It also has a variety of libraries for testing different kinds of connectivities, such as SSH library for SSH and TFTP library for trivial file transfer protocol. And yeah, basically this is just page one. So Robot Framework also has an external library for specific needs, such as for data-driven testing on a huge array of test data with support on popular black box testing and test compression technique called pairwise combinatorial testing. Apart from that, it also supports desktop-based applications using Auto8 library integration with Robot Framework. And some other libraries basically support very specific kind of applications, such as you could see here, KiCad, MQTT, network protocol testing, robotic process automation, swing-based GUI applications, white framework-based applications, milling machines, and image recognition softwares. And if that is still not enough, it has a tons load more libraries for many different purposes, such as testing FTP connections, test data generation using this robot figure, SAP testing, SOAP testing, other alternative libraries for web, desktop, and Java-based applications testing. It even has a dedicated library for testing IBM mainframe. So that's basically, just the more popular external libraries that Robot Framework supports. Lastly, Robot Framework also employs additional support tools to further empower its users in data manipulation, test execution, documentation, and so on. So we have here, for example, Rebot tool for test report management in general. And also we have here Pabot for parallel execution. So again, more on this later. Documentation tools such as libdoc and testdoc. We have a record and playback tool as well for rapid SQL action prototyping. So Robot Framework also has that one if you want to quickly automate your test. Again, it's just a matter of starting the recording and then doing the user actions and then stopping it. And then the system automatically records all of those for playback later. It also has a tons load of IDE plugins for various IDEs such as Eclipse, IntelliJ, VI, what else? TextMat, Atom, Emacs, Visual Studio, and the list goes on and on and on actually. And apart from that one, of course, it also has CI/CD plugin to easily integrate Robot Framework with popular CI/CD tools such as Jenkins, Maven, and Ant tasks. And finally, a very useful tool for self-distribution of Robot Framework tests into multiple machines and or Docker containers for parallel execution. So we have that one as well. And together with your CI/CD setup, distributing test automation tasks across multiple agents, and Pabot library, as I mentioned earlier, enabling parallel execution by utilizing the number of CPU cores in your system, you'd be finishing your automated test execution, with just a snap of your fingertips. So that's how fast actually Robot Framework executes your test cases. And of course, that's not it actually. So the list of tools goes on and on and on. So we have tools for report consolidation, static code analysis, performance or load testing using this RF swarm, monitoring system integrations. We even have this, our robot framework even has this voice over or SMS controlled test process automation via your own personalized virtual assistant, and basically so much more. So it gets better and better every time as support and new features come by frequently. With the last, again, I've heard having robot framework support testing or process automation of elevators. So really, it is even a huge understatement that robot framework is flexible in a sense or in a way that it's supporting different types of applications requiring different types of testing strategies. Plus, as I've mentioned earlier, if this is not enough, Robot Framework can easily support custom-made libraries in Python that can easily be integrated to it by importing the Python package. Again, coming from experience before in my former projects, we were able to create an auto-deployment script for a performance testing framework and integrate it to Robot Framework, along with custom KPI monitoring scripts using Prometheus stack deployed in the test server. This and actually so much more. So it's just the limit. The limit here is actually your imagination. Of course, your scripting knowledge. Because again, even with all of these libraries already very much available at hand, you could easily create your own custom scripts, not only in Python but also in Java as well. Okay, open source. What does it mean when we say that an application is open source? Being open source means that it is basically free to use without licensing, and you could easily download the application with all its source codes and basically do whatever you want with it. And as a result, this empowers us to have the highest level of flexibility in the framework to which we can easily customize and modify it to adapt to our specific testing requirements, yet still achieve a very high level of maintainability with its third-party external libraries being developed and maintained by other parties, allowing us to focus again on what is essential. And by essential, of course, it's basically creating the automated scripts itself, basically ramping up the automation, the processes involved, also expanding our testing coverage, our testing domain, and so on and so forth. So Robot Framework has a very active community as well. So we have here Robot Framework community. It also has a Slack community team chat. And finally, this Google Groups community mailing list to, of course, answer questions, for example, to help out our fellow Robot Framework users. So it is the framework of choice by over 70 different companies using many different types of applications. It was actually initially started by Nokia and was since then open sourced, used, and trusted worldwide, including, of course, Fontaine. So now that we know what it is, let's take a quick sneak peek of Robot Framework and see what it really looks like for one of our web-based applications. Okay, at the low level, we have Robot Framework keywords, which are the building blocks of the automated test itself. They correspond to the basic actions you'd want Robot Framework to do for you, such as clicking a button, inputting text to a text field, verifying field values, and so on. These keywords are, as you can see here in the code snippet, human readable. It's like, basically reading the test steps itself from the test cases. And oftentimes, test automation developers create what we call page object models that defines, in a single file, all the things an end user can do in a particular web page. So for example, in many applications requiring user authentication, you'd expect or we'd normally have keywords such as input username to username field, input password to password field, and of course, click login button. And as you could see here, basically we have, for example, click store button. And we also have here keyword for inputting office of entry exit under header tab keyword, which basically, as the name suggests, inputs a particular value in this office of entry exit text field. We also have this verify office of entry exit under header tab, which basically verifies what's inside of the text box. And finally, a keyword for uploading file under the attached document tab. Okay, so again, let's go through this one at a time. So in this particular, for example, on the screen cap, again, you could see here this click store button here, which involves, as you could see here inside the keyword, we have defined here in basically waiting until that particular web element is enabled and clickable. And then it involves as well scrolling that element into view defined by the next line in that, and then clicking that particular element, and then finally checking that the store operation is successful by waiting for a notification message. So again, it's literally like reading the test steps, and you could, doesn't even take, someone that's, very much knowledgeable or adept into programming to, more or less create or start creating their own automated test cases, because this keywords here, actually, this wait until element is enabled, click element, check if notification message is present. These are basically already created for us by, by third party, basically third parties, and it's just a matter of, importing these libraries and, directly using it as well. Okay, in the next here, we also have another keyword for inputting office of entry exit value to a text field under a header tab, which mainly involves, waiting for the text box to be enabled and then inputting text to it. Other keywords include text field verification in the third keyword here, and finally uploading of a file, which involves a series of steps as indicated below that one. So you can see here, for example, under upload file under attached document. So the first thing that the system would do, and also as a user would do, is that it's going to wait until the element is enabled. So you can see here, next to that wait until element is enabled, you have here that it's waiting for the upload file button. And then the next step is that it's going to click that one. So we have here click element. So it's going to click the upload file button there, and then wait until element is visible. So it's waiting for basically another element, then choosing file. So that's where we choose the actual file that we want to upload. Wait until element is enabled. So it's basically waiting for this start upload file button, and then clicking that element. So it's going to click that button, and then lastly is that it's going to wait for the element or for an element to be, not anymore visible. So in our case, this is the upload file module or basically model. And then second to the last, we have here wait until page contains a particular, for example, element. So in this case, we're waiting for the upload confirmation. And then finally, we have here wait until element is visible. That it's basically waiting for this attached document to be already uploaded, and with a particular confirmation alert as well. Okay, and basically, yeah, the best thing is that even if I don't really explain it in much detail, almost anyone can easily deduce and understand what actions the user does when doing those test steps. And of course, if you want to start automating test cases using Robot Framework, again, it's just a matter of locating or finding the correct or the right keywords, or basically the more appropriate keywords that you'd want to use. So for example, if you want to click a particular button in your web page, then there's the click button keyword in Robot Framework, powered of course by Selenium library. If you want to, for example, input a particular value in a text field, then we have input text. If you want to, for example, what else? Scroll down to a particular element, then we have your scroll element into view, and quite a lot more actually. So we have a huge array of keywords readily available for us. So not only clicking, double clicking, what else? Context click or right click, and basically quite a lot, as we're going to be showing later. And finally, Robot Framework, I can't stress it enough. It's very much intuitive. It's like, again, literally talking to it and telling it what to do. For example, in this case, go open a browser, go to this web page, wait until this element is enabled, click this element, choose a file, scroll down to this element, and so on. So again, it's like teaching the system what to do. Now take all of those keywords and group and arrange them together according to its proper order in your test case. And you have your automated test case actually. So here's an example of a test case that checks the availability of the store operation for an application. Robot Framework has this suite level and test level setups and tear downs that gets executed prior and after the entire test suite and after each test case respectively. This is very much useful, especially in preparing your test environment. For example, opening first the browser, going to the test application, what else, and logging into a suite level setup and preparing test data and other test specific prerequisites at the test level setup here. Note that a robot framework can also make use of the Gherkin or Gherkin style development wherein the test cases are defined in the format given when then, which enables better readability from a business perspective. And with this, plus the keyword-driven approach, test cases cannot be any clearer, and I can guarantee that almost anyone can easily understand the automated test. So let's take a quick look at what we have here. So again, here, the test case is basically checking the availability of a store operation for a manifest via manually filling that particular manifest. And it's again in Gherkin and Jerkin approach. So we have here setup. So it's actually here, yeah. So we have here the setup first, wherein it's basically doing some test preconditions, like for example, setting special configuration of parameters. And also we have here the preconditions or the necessary steps for the test case. So given that the user navigates the manifest application, when the user does this series of test steps, then the user checks the manifest status or checks that the manifest status is basically stored. But yeah, let's go into a more simpler approach, I suppose, or a more simpler example. So you could see here another example, a sample test case, and its keywords used to test a sample application or basically application authentication system using username and password. Here, you could basically see that I place a documentation for the test case so that people reading the test report are able to gather some information about it. So normally it would be a bit lengthier to some point that in my past projects, for example, we literally placed our test plan and integrated it with robot framework itself. Now, apart from that one, you just need to import Selenium library here, which contains the keywords used for automating user actions. So Selenium library is a powerful library that again already contains all your keywords needed to execute user actions, something that will go deeper later or basically in tomorrow's session, and then put basically the suite level setup and tear down here that basically opens the browser and close the browser for us before starting the execution. Then you define your data variables below it, and finally define the test cases itself. So here you could see that for the sake of clean code, I even placed here or grouped together keywords found at the latter part of the script here, such as user to navigate to the test application, user inputs valid credentials, and user validates successful login to the application. Okay, and with that in mind, finally in the test case we have here is just a matter of really literally reading the test case as it is. So the test case basically says that given that the user navigates to the test application, when the user inputs valid credentials, so you can see here that it's setting or inputting the username and password, then the user validates successful login to the application, provided of course that it was, the user input the valid credentials, the valid username and password. So again, it's very much similar to the test cases, as we normally define it in the test plan. All right, the next one and second to last is the test reporting. So now that we have already have our keywords and test cases, the next step is on test execution. Now, how a robot framework does this is that take any system or application that has an available terminal or support for it, run a single command, and you would have the automated test run before you. So it's just as simple as that one. This is true not only for standard Windows command line or Linux terminal, but also for example, IDEs having that terminal supported, such as in our case, Eclipse. And if that's not enough, Robot Framework also has a very extensive API, enabling its test cases to be easily executed using API calls through any tool or application having API support. I mean, you could literally run Robot Framework through voice or text message from your mobile devices if you like it. What's more is that you could easily integrate it to any CI/CD tools such as Jenkins, TeamCity, and GitLab CI, to name a few. Now, with that said, it does not end there because, as I mentioned earlier, Robot Framework has several tools used to further enhance the performance of your test execution. And for example, Robot Framework enables tests to be run on parallel on the same server and or have it distributed across a grid of testing environments. So more on that again in tomorrow's session, where we further deep dive into Robot Framework and have an actual, basically run through on how we would start or basically start automating our solutions using Robot Framework. And finally, Robot Framework also has a built-in feature to automatically re-execute failing test cases for some flaky tests caused by intermittent network failures, environment problems, and the likes, and then automatically merging the results from the former run to the latter, producing one coherent test execution report. And finally, speaking of test execution report, Robot Framework produces several files for reporting. One is an HTML document containing filterable test results or test suites, test cases, and the corresponding keywords executed. So here in the snip, you could see the hierarchy of test cases, the keywords, and further keywords executed inside it. Passing and failing keywords are also highlighted here in green and red color for us and could be collapsed or expanded accordingly for troubleshooting. And Robot Framework also supports the automatic screen capture of the UI for web-based applications, as you can see here, enabling us to quickly get insight on the possible cause of the failure. So in this case, for example, as you can see in the image on the right, the test case is failing because we failed to input a value in one of the mandatory text boxes in the UI. So it's, okay, not quite sure if it's visible, but you can see here that there's a red here, meaning that it's a supposedly mandatory field. And with that, of course, this one is, clickable and you could see it in full screen. But with this one, what I mean to say is that with Robot Framework, we already have an instant analysis and troubleshooting within just a couple of seconds. So you don't anymore need to deep dive on the logs of the system and all those things because it captures the last status or state of the UI that we're testing. And with that in mind, this wraps up day one of our Robot Framework info session. So again, stay tuned because tomorrow we're gonna be tackling more about Robot Framework and its use, especially this time around, we're going to be dealing with how to empower your test automation through continuous integration. So as I mentioned a while ago, I've had a few rundowns on what continuous integration is. And so how do we start, integrate our solution to the CI tool and how powerful test automation would grow with this in mind. And of course, all of that using Robot Framework. And with that said, any questions so far from the team here? So let me quickly check on the chat here.
Yeah, we have a couple of questions our participants sent to us. So maybe we take the first one. The first one is from JC Suarez. What are the usual errors or failures that happen during the build or automated execution? So maybe I will answer this one. So most common errors that we found during the test executions are the bug itself from the software, and second, the script errors that we introduce in test automation. However, it's when it was a script errors, we could easily fix that. Therefore, it will not go to the actual testing or actual test execution when we do product evaluations. However, for the another failure, which is the software bugs or the defects on the product, we usually raise issues to the delivery team or maybe to the development team enable to fix that.
Yeah, thank you very much, Noel. And also to add to that one, it's also not, uncommon that we also encounter problems such as, for example, issues with the environment or even just simple network latency issues. Or for example, someone, accidentally does something to the system. And with Robot Framework, as I've mentioned earlier, Robot Framework allows this or has this feature to automatically execute your failing test cases. So with that in mind, you won't anymore have to deal with those intermittent issues and you would be left with those really, more consistent issues like as Noel had mentioned, software defects. So that's a very valid defect. And of course, problems with the actual test scripts itself, something that of course need to be resolved in the actual automated test scripts. All right.
Yeah, we could proceed to the next question that we have here. So, how do we determine which test cases are good candidates for automation?
Yeah, maybe I'll, or Noel, do you have a answer?
Yeah, for me, the good candidates for test automation are being determined and discussed by the development team, including the software engineers, developers, and the QAs. Therefore, we have this initial assessment. What are the test case or what are the priority of these test cases that is good for test automation?
Yeah. And of course, to add on top of that one, what, as Noel had mentioned, what the stakeholders would normally consider, if you actually anyone and even ourselves, what we normally consider as the best, test cases to automate are those actually that A, they are the ones that are consistently failing. So they're, what we call as, clustered test cases. And B, those test cases that are very much high risk. So these test cases are the ones that are normally containing the basic functionalities of the system that, of course, if those tests fail, then the application won't be usable at all. And C, those test cases that are very much hard to execute because it takes very much time to execute those. So example of this, of course, performance, again, and don't get me started with, manually testing 1,000 users simultaneously accessing the web-based application, for example. So those are best possible candidates for automation. All right, next question. What else do we have?
Next question on the list. What are the prerequisite skills in order to start working on robot framework?
I wanted to answer this one.
Yeah.
Okay.
Um, any tips on how to get started with robot framework? So please stay tuned tomorrow because I will be discussing what are the things, what are the tools that needed for robot framework to start with. So please stay tuned tomorrow.
Exactly. Yeah.
Yeah.
Yeah. All right, next one.
The next one we have here is there a PDF you can provide so we can follow through the presentation and still learn from it after the event? So I could answer this one. Initially, from our organizers, we will have a recording that will be sent to your email after this webinar. So you could check on that and refer that recording in the future. Right. So next questions we have here. Uh, can robot framework integrate with Azure? So as initial idea, for us, we guess that we could robot framework could integrate in Azure, but we have not yet checked on how it will be done. But I guess there will be some online resources on how we implement test execution or test case executions using the Azure.
Yeah, yeah. And just to give an idea on this one, again, I'm no expert with Azure, but Robot Framework again has this public APIs. And also, again, as I mentioned earlier, Robot Framework is able to execute, for example, external scripts as well. So if Azure supports those, then it could, there's a possibility, of course, that again, those two tools could be integrated.
Right. Question we have here is sometimes the UI components doesn't have proper IDs, not reachable by expat. Can robot framework resolve that gap? Right. So I could give an idea on how we could do a workaround here. So based on experience, robot framework not only supports ID, not only support
Mhm.
expat, but also supports different type of locators such as jQuery, CSS, and many others. So with that in mind, as long as the expat is reachable by one of those indicated locators, we could automate that or we could reach that component. Also, I guess there is a specific keyword in Selenium library that have the robot framework, which execute a particular JavaScript. So
Yeah,
in
exactly.
case those locators are literally not reachable by the basic locating elements, we could use the JavaScript to reach that. All right. So I think we have a minute left. So maybe one last question here.
All right.
S- So what are the practices on how you are able to maintain numerous tests? So
Uh, yeah,
yeah,
go
go
on.
ahead. Go
Go.
ahead, Jason.
So what are the practices on how you are able to maintain numerous
Numerous tests.
tests? I'm not quite
Yes.
sure if I get the question correctly. Noel, maybe you have an idea of this one.
Regarding with maintaining a large number or maybe a small number of tests, it's all about on how
Okay.
we architect the structure of the robot framework enable for us to easily maintain not only the test case itself but also the ongoing additions of test cases in our structure.
Yeah.
So in line with that, I guess there will be some discussion tomorrow in
Mm-hmm.
line on
Mm-hmm.
how we could structure, if not properly, but we could give you a idea on how we do it, enable to for us to maintain that test cases or a large number of test cases.
Yeah, yeah, I agree in that one. And also just to add to that one, it's actually two parts. So test automation goes hand in hand with, of course, test strategy, test approach, and basically just simple test plan creation. So it starts first with the actual, organizing of the test plan, ensuring that the test plan is very much, comprehensive yet compressed, and also, trimmed down to the very core. And from there, we identify the test automation suite from the test cases that we need to automate. And as Noel had mentioned, tomorrow we're going to have a discussion on basically how to get started with automating your test cases using robot framework. And with that in mind, we're also going to be giving some hints on how to structure the actual framework itself. So the suggested directory structure, how to manage the tests, where it's going to be located, how to manage the variables, even environment configurations. We're going to be discussing how to be able to integrate that and how to manage that properly within robot framework architecture. Yep.
Yeah, I guess that's all for the
Yes.
questions for now. However, for the remaining questions we have, we will get this and we'll reach out to you to answer these questions.
Yeah. So once again, on behalf of the entire team, of course, on behalf also of Webb Fontaine, thank you very much. And see you guys tomorrow for part two. So don't miss this out because again, we're gonna be deep diving further into robot framework. So this is just the tip of the iceberg. And for further questions, inquiries, applications, even please send an email to hr-ph@webfontaine.com. Again, thank you very much. And of course, have a good day.
Thank you.
Thank you.
Have a good
Bye.
day. Bye, guys.